In a previous video, we did something where we made a damage system, specifically a type weakness damage system, because a lot of RPGs are going to need that. But the downside to the way that we made that system is that we needed to define the weaknesses or the strengths against every individual type of enemy. Which, if you're making something that is a little bit larger in scale, is going to be a bit of a pain. And that's where things like a Pokemon-like type system might make a lot more sense, because it's a lot more scalable and almost feels procedural in nature. So that's what we're going to be making today. It's going to use the same principles, but we're going to make it get all the types together and do all of its magic calculations. And at that point, you only need to give types to your abilities and types to your actors, and then the system will figure everything out for you. So we're here in an entirely empty Unreal project. At the end of this, we'll have a working system. The download for which will be down below in the description for YouTube members and patrons if you want to help support the channel and just mess around with my code a little bit. So first things first, we're going to do something very similar to what we did before. If you haven't seen the other video, don't worry. We are just going to start from scratch here. We're going to make some types. I'm going to be using the built-in damage types that Unreal has. This is not really what they're intended for, but you can send through a damage type with the built-in applied damage system, which is nice to be able to use, so that's why we're using this. For my own uses, I would probably prefer making these enums instead of making them like specific type classes, but for now we're just going to go with this. And we'll just make fire, water, and grass again, which are the exact same ones that I used in my previous example. Let's make a actor for this. So I don't think we need to particularly have a character or a pawn for this. A normal actor will probably be fine. And we'll call this Pokemon, or let's call this a pal, just to mess with Nintendo. So your pal is going to have a type. And the wonderful thing about this is, while Pokemon and games like even Pal World and a lot of Pokemon copycats only limit Pokemons to having 2 types at any given time, in theory, there's nothing to stop us from giving a arbitrary amount of types to every single Pokemon. Of course, the balancing of that is going to be hell. So you probably don't actually want to do that, but from a programming perspective, it doesn't really matter, because what we're going to be doing is we'll make a variable, and this will be the types of this Pokemon, and it's going to be of type, damage type. It's not going to be an object reference though, we're going to make it a class reference, and I'm going to make this into an array. And here you can see that I can just add as many types as I want, so I can make a Pokemon that is fire, grass, and water at the same time. And the code that we're going to be writing is just going to iterate over this array. But before we can write any code to do with any of that, what we want to do is we want to make a blueprint struct. So we go into blueprint, struct, and this will be our type weakness. And this is going to, if you've seen the previous video, be very familiar with you. This will be the weakness table, which is going to, again, be of type damage type class reference. And we're going to make this into a map. And it's going to contain a float. So for every single type that we're going to be making, we're going to add in a float for the damage multiplier on it. And we're going to give this some default values as well. So we're going to make a default value for water. Default values are always going to be 1. And fire and grass. And I'm adding these in exactly the opposite order of what I am saying them out loud as. And as you add more typings, you can just come back in here and add one more, like environmental damage. It's one of the base classes that Unreal provides you with, which is going to stick with fire, grass, and water for the time being. And unlike what we did before, we're not actually going to make a data table of this, because data tables work based on names, and that's going to be a little iffy to set up properly to get the name of a class. Especially if you're doing this entirely in Blueprint, getting the display name of a Blueprint class can be a little iffy sometimes. So what we're going to do instead is we're going to go back into the base PAL class, and we're going to just make a quote-unquote data table in here. It's a little less sophisticated this way, but will probably survive. It might be nice to do this on a separate component as well, instead of as the base pal class. The code is all going to be the same, but it's just going to, you can place it wherever you want. This will be our type weaknesses. And this is also going to be a damage type, but instead of having a damage type array, this is going to be a damage type map, and the type of which will be the type weaknesses. So what we're going to end up having is we're going to have this map with a bunch of different entries in it for each one of the types. So we have grass, that's more of a 6 than a G, but hey, whatever. We have water, and we have fire. And on each one of these is going to correspond to a map that then maps out how this specific thing reacts to each one type that exists. So let's just compile this and show that off. Because if I make a type weakness here, we can choose, for instance, fire. And then if I expand this, it has a weakness table for fire. Well, fire is going to, of course, resist fire, so it's going to only do 50% damage. But then it is going to also resist grass. So keep in mind that this is the defensive side of things. We're programming the defensive side, not the offensive side. So this is when a fire type gets hit by a fire move, by a grass move, or by a water move. How is it going to respond? So grass is also going to be resistant, but water is going to be super effective. Then we can add in the next one, which is going to be grass, which of course will have fire, be super effective against it. And then the other two will be neutral, I think. And then we do water, and you can do whatever you want with other types, of course. Water is going to resist fire, resist water as well, and be weak to grass. And again, expand this as you see fit. This effectively still works as a data table, but it just takes in a type and puts out a number based on what other type we're comparing it to. So let's make the function that actually does the magic, shall we? And we're going to actually do that as a function. So let's add the function, and that is multiply damage is what we're going to call it. And this is going to take in, first and foremost, an input for the actual damage that we're trying to do, and that's going to be a float. And here you need to pay attention. We're going to open up the little arrow here, and we're going to set this as pass by reference. So this way, inside of the function, we can start editing the actual value of the damage that we're doing, and it will reflect to the actual damage value outside of the function then as well. Without this, we're just passing in a copy, and any editing that we do on it here won't reflect outside of this function. And then we also take in the damage type. So this will be the attacking type. Here's what we're going to be taking in, which will be a damage type class reference, of course. This doesn't need to be a pass by reference. We can just make this pass it by copy. And then we also set in the defending type. And then what we'll do is we get our type weaknesses, this array, and we find the defending type. Again, we're setting these up for the defending type, right? So when a fire type gets attacked by a water type, that does 2 times the damage. So we first find the defending type. That then gets us another map, which we find the attacking type in. And that finally gets us a float that we can use as a multiplier. So we'll take in our damage, and we will multiply it. So add in the multiplication with this. I'm doing this as a multiplication because that is how Pokemon works. If you are super effective against both of the types, you don't do 3 times the amount of damage, you do 4 times the amount of damage. So if we extrapolate that, in theory, if you had 3 types that you're super effective against, you'd be doing 8 times the damage, and 4 times. With 4 types, 16. With 5 types, you'd be 32 times the damage, and so on and so forth. If you want to make it additive, where you just add another 100% for every type that you're super effective to, you of course wouldn't do this multiplication. You do some other math, but we're going to stick with this because I want to stick as close to Pokemon as possible for this example. And then after we multiply it, this doesn't yet set anything, right? So we set by reference ref var. And that just allows us to set the actual damage to a new value that we just calculated. And this is effectively everything there is to it to make a Pokemon damage type system. So now when we receive in damage, so on event any damage, we get the damage and we get the damage type, which is all that we need. So what we do is we make another function real quick, and that's going to be a function that deals the actual damage. So let's deal damage, and this function is going to take in the attacking type, and also then it's going to take in a float for the base damage, which going back into the event graph, we can just immediately hook up to this. The base damage is going to be the damage that we get from event any damage, and the damage type we can just get the class out of and set that to the attacking type for it. So the base damage, what we're going to do is we're going to make that into a local variable. So let's call this damage, and that's going to be of type float, and it's going to be a just single value. First thing we do is we just set our base damage to that variable. Then what we'll do is we'll get the types that this Pokemon/pal has, and we're going to for each loop over every one of its types. So that way we will do the multiply damage function only for every single type that it has. So if it has one type, say water, it only does it for water. But if it has 5 different types for whatever unforeseen reason, you might want to do that. It'll do this for every single one of your types. So we hook this up into the loop body. Our damage local variable is going to go in here, and it's going to get multiplied for every single one of these operations. So it very well could get multiplied up and then back down, and then back up and then back down, because it might be super effective against some things and then not very effective against other things, and this is all going to make that balance out. So we just provide in the attacking type from our input here, and then the array element is going to be the defending type. That's going to be all of the individual types that this Pokemon possesses. So that'll go into the defending type. Then at the very end of this, your damage has been multiplied up and down and sideways in all directions, and now we actually have the final damage to apply. So assume that we have something like a health variable. We then set that health variable to health minus the damage that we've just finished calculating. And of course, we might want to like max that between that value and 0, so that it clamps it down to 0. And now we have a Pokemon damage system that is expendable with more types than you would probably actually want to be able to put on a singular enemy. But maybe you have like a super powerful final boss that is every type in the game at once. You can very much do that with this system now, and it'll hold up to any amount of types. In theory, you could even make something the same type twice. We could make, if we wanted to, a fire type. Just would be very weak to water. You could do that. And obviously, if we add in a little bit more stuff, if we just like copy this over and we add things like ghost and normal type to this as well, going back into our pal, into our type weaknesses, let's add in both ghosts and normal. After we make a new type, we actually should go into the struct first and add these in there as well. So ghost and normal, of course, the default values of which are all going to be 1. So now we do need to go in and add the ghost and normal type to every single one of these types, but like you're not going to have that many types, so this is not going to be an issue that you run into too often. We can just say normal 1 and then ghost also 1. So this is slightly tedious, but you'll probably make it through just fine. We're going to ignore the thing for water now. What I want to say is ghosts, of course, against normal types will be 0% effective. It'll just be immune. And normal types, the same against ghost types. They are 0% immune. So with this system, that also deals with that. Because if there's any 0% effectiveness in there, it's going to multiply by 0. Your damage output will now be 0. And no matter what the other multiplications are, your base damage has now been set to 0. So it suddenly just doesn't have an effect at all. So you can be creative with this in any way that you like, and you can make a game that'll get you sued by Nintendo. Isn't that just fun? And a very big thank you to all my Patreons. You can see them on screen right now. If you want to help support the channel or get any of the project files in any of my tutorials, there's a link down below to the Patreon page to support me, or alternatively as a YouTube member. And of course, an extra massive thank you to my Cave Digger tier supporters, Sir J. Thomas,